A system has reached equilibrium, where all the concentrations remain constant, the forward reaction rate is equal to the reverse reaction rate. We can manipulate the system by disrupting the equilibrium, applying a stress, such as a change in a concentration, the temperature or pressure of the system, and then the system's equilibrium is disrupted. So if this line with this green dot represents the place of equilibrium, we apply a stress. A change in concentration, temperature, or pressure would be some common ones. We see that the ball is pushed to one side. The system is disrupted. It's no longer at equilibrium. And what happens is the system really wants to be at equilibrium. So the system makes adjustments to reestablish the equilibrium. So the stress pushes the system out of equilibrium. The system makes adjustments and to reestablish new equilibrium. So we can manipulate a system at equilibrium, stress it, and in the process of the system readjusting, we get the system to do some work that we want to achieve. So this is a lot of patterns, and Le Chatelier is a scientist who came up with the principles of how a system will readjust to a stress. So here we go. So for you to be able to apply Le Chatelier's principles at a foundational level, first identify the stress that's disrupting the system. Is the stress on the reactant side or the product side? So the stress, is it a reactant or a product? And then determine the direction that the system will shift. So if the system shifts to the right, that means it favors the forward reaction, where the reactants are making more of the products. The forward reaction is favored. Or the system shifts left, where at this point of the readjustment, the reverse reaction is favored and the products are making more of the reactants. So one of the reactions, either the forward or reverse, will happen a little bit faster until the equilibrium is reestablished. There's a pattern here. So we have two major types of stresses. A stress could be described as an addition, where we add something to the system, or we increase would be a way to describe that something's been added to the system. So basically, more is put into the system. Now there's too much of whatever was put in. So the system, the way it deals with some sort of addition, is that the system will shift away from the stress. So if the addition is a reactant, the system shifts away from the reactant side. If the addition is a product, the system shifts away from the products. The reason the system shifts away from that addition is that the system has to use up some of the extra, and it uses it up by making more of what is ever on the opposite side of the arrow. The other major category of stresses is a removal. So something is taken out, or it has its concentration, temperature, or pressure has been decreased. So if it's been taken out, now some of it is missing. So if it is a removal, the system shifts towards the stress, because the system needs to replace or remake what was taken out. And it makes it from the substances on the opposite side of the stress. So we're going to take these ideas and slowly work through them.